No dobra. Okay, hello everyone. Welcome to zkWarsaw 15. The format for these meetups is we meet once a month. Usually, you can learn more about the meetups at zkWarsaw.dev, and we would like to extend our thanks to our partners, vLayer, represented here strongly, and Ethereum Support Program, Ethereum Ecosystem Support Program, I think, ESP. The topic for today is gonna be T and DeFi, and specifically the application design space. That's what I would have said before I looked at the slides in depth and figured, no, we need a last-minute change. Let's talk about accepting compromises instead. Now, I did minor in psychology, but I do not regard myself as a psychologist, more an engineer. And this is gonna be an engineer's view on accepting compromises. And just as I was thinking about what to discuss today, Piotr just happened to reach out to me and figured, well, it seems like, we figured, hey, it seems like the world today is growing a bit less religious and a bit less orthodox about never accepting any security assumptions over math to verify it all and nothing else. So that's why I'd like to talk a bit about where I view there might be a synergy for trusted execution environments, a specific kind of increased security assumption without insulting the cryptographers amongst us too badly. And so, because we are an intimate crowd here, I would encourage discussions and, both clarification questions as well as ideas and inputs as we go. The outline for today is going to be, I'll share a little bit of the context and the compromise rationale from a personal standpoint. I might give a recap of zk. How many people know about zk, like what a zkP is? Okay, maybe no recap necessary. How many people know what a TE is? Trusted Execution Environment? This is very humble. Okay, cool. So maybe we can skip the recaps and jump right into why compromise. And the specific application space that is novel and that I'd like to focus on, that grew to become my interest over the last few months, is DeFi, and specifically enabling an LVR and MEV-free DeFi. Now, who knows what LVR is in DeFi? Okay, cool. So we'll have something to talk about. Cool. So the context is, I'm an engineer, and when I started my first company 9 years ago, I was one of the 2 engineers on the co-founding team with 2 other problem domain experts, in our case medics, and it would remain our burden every few weeks to tell our co-founders, hey, this product idea of yours is great, and it will take 1,000 years to build it. Maybe it makes sense to consider some medium ground. And I think this is a reality for many people and many engineers who are faced with product people or domain experts. And I think in the case of crypto, this is a very specific domain expert, as in it's people who really like research and hard problems in cryptography and remaining pure. And so I think in crypto, an engineer's task is to sometimes try to bring down those very high and pure research ideals to the engineering reality and try to make compromises where it matters. So that's basically where I come from. And then I joined Scroll, and at Scroll we figured, oh damn, like there's all those high trust, like low trust assumptions that we aspire to, and it would be so cool to only have like trust in maths and so on, and it would take 1,000 years to build that. And so we would be faced again and again with the decision which trade-off to make, and where to actually not sacrifice time and I guess sanity in favor of staying pure, and where to. And so I'm trying to find out, maybe together with you, what a sane compromise might lie with respect to where P's are actually a viable choice. There's problems in crypto. That's why we are here. We want to solve those problems. And the problems that I would like to bring your attention to is when designing crypto systems, we have all of the engineering, mundane to-dos that can make or break a system, including bugs. We also have the entire cluster of scalability and solving the so-called trilemma, and maybe making a trade-off there. We also have the cluster of privacy. I think that's interesting to many of you here, where we still haven't figured out how to really establish it in a scalable, production-ready way in crypto. And lastly, I'd also like to focus on DeFi as a problem domain where the execution is oftentimes worse than in traditional centralized markets and exchanges, where liquidity is siloed and fragmented into different chains, and also where the user experience is universally accepted to be terrible, and a big portion of that is bridging between those chains. And so all of these four clusters, I would argue, can be positively impacted by making compromised choices. And I'd like to explore with you, and maybe later with, as part of my hopefully new startup very soon, how to resolve them in a way that suits the market. Now, you know zk. zk is deemed as the holy grail, and then it is costly, and it also introduces latency that I would estimate, even over the next years, will still remain on the order of magnitude of minutes for something like proving an Ethereum block, which is something to bear in mind when thinking, like, even if we have unlimited resources and we parallelize as aggressively as we can, what is the best we can hope for in a few years? And then make your choices depending on that. And so if you know, if this assumption turns out to be valid, that we will be faced with a few minutes of latency, we can straight away discuss some problems as not deem some problems as not solvable with zk. For instance, alleviating maximum extractable value, or building blocks. You will not be able to build blocks with zk if this assumption holds true. So that's why I'd like to talk about compromises here. And so some people would say the T is a poor man's zk. It's like the ugly compromise. But I'd like to introduce a little question mark behind that ugly bit, and try to find out a synergy, or look for a nice sweet spot where maybe even the religious amongst us will find it appealing. And so what is a T? A recap here. Also, most of you know the basics. So briefly, it's a system where there's a certain amount of trust being placed with the system's vendor, that basically you can envision as in the vendor putting a private key somewhere in into the hardware, such that it'd be difficult to extract that private key by the user by an agent who has full access to said hardware. And so what this leads to is the ability for me to trust that guy's execution, even though I don't trust him, and I know that he has full access to the machine executing said code.
But I think it's worth to mention that you trust the hardware.
Exactly, exactly. That's the trust assumption. I would break it down, the trust assumption, the increased assumptions that we need to accept as you trust the vendor to engineer the system properly, and yeah, that there be no bugs and so on. That it be indeed, let's assume for simplicity's sake, impossible to extract the private key. You also need to trust that vendor to maintain a database of public keys of those units that got shipped and maybe updated occasionally as certain units are deemed as compromised, maybe by state actors or such. And also you need to trust this what we call remote attestation logic system that allows me to verify that indeed this guy's computation was attested to, was signed off by the private key from the hardware. Right, so that's what we trust. And this is, okay, you have, do we have a microphone maybe for the audience?
Because already there are research that, for example, Intel uses kind of tricks to generate entropy. So
I would view it as this item. So trusting Intel engineered private key generation and putting it into the hardware properly, wouldn't you? Like, if the entropy is not random enough, I guess that's like an engineering fault, an engineering failure.
Waiting for the ramp on weakness of those security assumptions.
but also it's
Later part of the presentation.
difficult to differentiate whether the weak entropy is feature or bug.
Yeah.
Depends.
Of course,
And if you're NSA or someone else.
Exactly.
of course, yeah, yeah, absolutely. I think that's a valid point, yeah.
I think there is also an implicit assumption here that Intel tries to make zero compromise there, but it's their compromise multiplied by our compromises.
Yeah, so some people do.
We're holding on the rand of security, weakness of security assumption to the later part of the presentation.
So I know there's some people claiming that, for instance, there be an incentive structure on the market where the vendor is incentivized to be fast rather than secure with a trusted execution environment. So yeah, I'm happy to discuss these, and I'd love to learn more over just SGX and the AMD system, actually. But then, if we assume that we accept these trust assumptions, we get this very cool system where all of a sudden, can I trust his compute? And his compute is maybe just a few times, 10x or so, slower than native. Rather than a zk system that maybe gives you 1000x slowdown, and then you still don't have a shared private state, so you still need something like FHE or MPC. So that's like another few orders of magnitude of slowdown. So that's the benefit. And so now I would argue, I would encourage you to wonder about where this might make sense. Like what sort of, for instance, value you guys would feel comfortable accepting as secured by these, I agree, high and not pure trust assumptions in order to gain this set of benefits. And when we draw a line and we say, okay, like above this value, maybe I want a zkP. Okay, so my buzzwords and stimuli for some thought about classifying the ugliness of this compromise are, do we need or do we aspire to have something like perfect forward secrecy, where we want maybe a property to the system such that if a future key is compromised, a future, for instance, T node is compromised, the past communications or maybe future communications of other nodes may be compromised as well. So this is something to ask ourselves about. I would also wonder about whether we can maybe only temporarily, I should say, heighten our trust assumptions, like have more assumptions that we would like to, but only maybe for a millisecond, or maybe only for a year, or something in between. I would argue increasing those security assumptions for something like block building to prevent MEV for, say, 12 seconds with Ethereum. This sounds like a pretty good deal to me. And third, I would ask myself, what's the worst that can happen if, let's say, Intel turns out to have been malicious, or if there's like a very serious bug, like what's at stake? And so in the MEV scenario, that would maybe mean, okay, like ever since this bad thing happened, malicious actors have been able to sandwich attack you guys. Sounds acceptable to me, like the worst that can happen. And so why bother? Like, why am I talking about math all the time? Like, we are about zk, right? Well, I would argue this fast, but still somewhat confidential, somewhat plausibly private compute has benefits and has trade-offs that may be worthwhile or may not be. And I'm trying to understand, for instance, where a certain bridgeless user experience, as in you have a TE execute some things for you between two consecutive Ethereum blocks, may be an interesting value add. Where you still have Ethereum check whatever happened since the last block and attest to it, but whatever is happening in between could be done in a way faster paced environment. And this would effectively mean you might have some use cases that you would traditionally only deem realistic on an L2, like a 200 millisecond block time Arbitrum, on Ethereum without forcing the user to effectively bridge funds. And so there's some new use cases that we've been seeing lately, specifically combined with zk. For instance, both Scroll and Tyco, they're eyeing using a TE proof as a second factor of authentication for the zk. And this has this nice property that you could at least identify when there is disagreement between the zk, what the zkP says and what the TE proof says, and then maybe act accordingly, like slow down the system or have a security council decide which way to go, or maybe you could have some more sophisticated logic there. And the way Scroll is thinking of doing it is adding an SGX proof on top of a zk proof to further go into this multi-prover vision. But Tyco has an interesting approach where they first post a T proof on Ethereum, which results in hopefully a very, very fast finality when if you are good trusting just the T proof. And only after some time is it going to be that they will be periodically posting a zkP, so that you can't, like a T compromise will not be able to have stolen change too much of history. I'd like to think about it as a checkpointing solution. And then there's all sorts of gaming applications and things where maybe the stakes aren't as high and the latency requirements very much are very high. But I'd like to focus on DeFi, and that's why I started with MEV and LVR. And deep dive into that a little bit and share some of my thinking. And that's something we'd like to focus on, my co-founder and John and myself, in the next few months. So we are researching this actively, and I'm curious to hear your thoughts. Do you guys have any questions so far? Does this make sense so far?
Perfect sense.
Cool. So yeah, my claim is even OGs don't use DEXs. It's 2024. And if you want to go trade your coin for USDC, you probably don't go to Uniswap. Or do you guys? Like, who here uses a DEX more often than SEX? Who uses a SEX more often than a DEX? Yeah, me too. And I was...
DEX is for exchanging tokens,
Yeah.
and SEX is centralized for exchanging money to
Yeah.
fiat.
Yeah. On and off ramping, yeah? Mm. No. Okay, so you would be what would be more coherent with the crypto ethos, right? But it turns out the fewest people are like that. And why is that? Well, I was preparing these slides for ETH, so that was in Amsterdam, and I wanted to draw a direct comparison between the execution rates that you would get on a SEX and on a DEX. And so I went to Binance.com, and wow, a gift for my presentation. I need to use a VPN. It's not okay to use a SEX, and still this is the biggest SEX on earth. Everyone uses it. That's where price discovery happens. That's where, where all of crypto is very much centralized.
But don't you think that you mix a lot of topics completely different? Completely?
Oh yeah, I'm trying to find where they can be matched. So yeah, this is an excursion, right? This is just to remind ourselves it's so easy if we have a SEX to like get locked out.
In DEX you can do exactly the same. In different tools, but you will receive on MetaMask, on RBC you can block.
Yeah, but you can run your node.
Good luck. Good luck.
Oh, I'm running my node. It's easy.
How many people here have?
How many people are running a node? Yeah, I know.
No,
How many people use a DEX? No one either. Like only Marek.
Really? You don't use DEXs?
I'm using.
How many nodes can you fit on this computer?
On this one? Well, I need to upgrade my SSD.
You only need $5,000 Magnum to run a node.
No, it's not that expensive. It's only the SSD. And also Nethermind just released an update. You might be able to actually run it now with 1 terabyte. And no longer 2.
Where to make simple transaction, we are forced to run and all.
So I think that it's not as simple as to say, okay, DEXs and decentralization is shit anyway because running a full node requires you to buy a 2 terabyte SSD because of the game design, because of the incentives. Like if, let's say, a regulator sees like these people can plausibly move towards not being reliant on a SEX within a few weeks or months, they will not act as aggressively maybe. Or maybe they will even more so, but I'm more in the first camp. So I think there's second order effects.
But that light is rather from the law point of view, not from the technical point of view.
Exactly, absolutely, yeah. Okay, so this was just an excursion. I found this funny. It would happen to me without me noticing.
I'm saying because currently we have a lot of kinds, a lot of battles, and a lot of counts of battles.
Yep.
And in my opinion, you completely mix two domains of battles. It's even not the same domain of the battles. It's
I guess my point would be, well, if you are able to make a satisfactory UX and execution rates-wise DEX, this will have implications on the legal sphere of things. That's why.
I mean, everybody here would agree that it would be great to improve in general, keep improving DEX's experiences, right? And there's still too much centralized exchanging happening. Too much exchanging happening on centralized exchanges. Right?
So my point is,
It's a noble goal to improve that.
So
I think one reason, just to finalize this topic, I think one reason people will centralize if you have a lot of money and you want to trade like $1 million of tokens, that's going to affect the price a lot.
I'm sorry.
And there's still more liquidity on centralized exchanges. So that's something we
Yeah.
definitely will change.
Yeah.
Although exchanges like CowSwap, for example, already improved on that
Yeah.
significantly.
Yeah.
Not
Totally.
by taking liquidity from multiple
Yeah.
sources.
Yeah.
Right?
Exactly. So how can we improve that? Well,
Yeah, we
status quo is this. Once you run your VPN and you want to sell or buy a Bitcoin, the difference between Binance and Uniswap is 4x in terms of price, in terms of fee. And this is just the spread. Right? That's status quo, and that is for a very big, highly liquid pair. It's way worse. I think Miko can speak to that more. If we look at a very long tail pair of assets. And so, how can we fix, what is the problem? Why is it so? Well, this is where I ask about LVR. It's called loss versus rebalancing. That's one of the effects leading up to this situation. And it basically says, this is an observation, that wherever there's two markets and one is faster than the other, and the price discovery is happening outside of those markets or in the faster one, the second market will always be prone to arbitrageurs who will basically be looking at the real price of an asset. Let's say Bitcoin was 70K in Ethereum block N, and 11 seconds later, those guys look on Binance, look on a faster market, and see, oh, Bitcoin is 71K now. And so what they will do is they will insert this loss versus rebalancing inducing transaction right at the end of the current block that will take advantage of the fact that Uniswap or an AMM has 12 seconds old information about the price. It thinks it's 70K, but in reality it's 71. So that one transaction will basically up this difference. And so there's always gonna be this loss, and you don't know which direction it's gonna be. So as a liquidity provider or user or platform, you need to take this into consideration and basically have larger spreads. So that's where one part of the problem comes. And a separate problem, somewhat related, but separate, is the general type of sandwich attacks and the like, or seeing, oh, this one guy is about to sell this huge amount of something, let me take advantage of this knowledge. So this has to do with the timing and with the fact that there's a public mempool, public transactions mempool, where you see what people intend to do. And there's quite some time that elapses until this happens. And then there's all sorts of games that block builders and bots can play with one another to reorder transactions. And so that's why I would argue, let us fix that, and let's look at how we can use a trusted execution environment to this end, and design it in a way where we maybe don't have those very long or high in value effects on security, but we only use it to secure maybe a user intent and maybe the order book. And so this way we could both look at fixing LVR, what we just described. We could look at front and back running attacks, and ideally also other kinds of MEV. This could be done with something that doesn't necessarily require a T, but I feel there's quite a nice synergy if you do it with a T. But there's more you could do. The reason why centralized exchanges are more efficient or like have better execution is also that market makers are able to actively manage the strategy, like what they, for instance, offer to sell and at what price. And this is very costly and slow in decentralized markets right now. Now, if you have a TE, could you actually use things such as looking into some centralized price feeds or having some logic that is only run inside the T that the T operator can't influence, that maybe even is proprietary to your market making strategy, and that would manage your market makers and orders. And then we could settle with fast finality. I think that's the most difficult one here, because in order to settle with a T-like, in order to settle every block, for instance, on Ethereum, you actually need, I fear, to trust the TE with your entire DEX. So I'm actually looking into how to weaken those risks. But you could consider that. Like, you could only require in your Ethereum contract that a T node attested to a given state of your DEX app, and then you could just view it as final, send funds back to the users on the L1. And so this is one of the ways to how you could enable a look and feel of a bridgeless system, where you don't need to go to a bridge and move your funds somewhere, wait for some time, then do stuff there, and then bridge those funds back to the original chain. Any questions about this? Or any concerns about this being not a good set of compromise trade-offs? Yeah?
I'm curious if there was a comparison for Binance versus like raw Uniswap. What if we use aggregators that also aggregate liquidity from RFQ, which kind of mitigates those concerns? Is it much better then, or still?
Yeah, RFQ is generally a lot better than AMM. And the way RFQ, so RFQ is request for quote. That means, do you guys know what RFQ is?
Like CowSwap,
Yeah, CowSwap has an RFQ mode, and so does UniX nowadays. This, I think, actually uses UniX and is actually already a better, like the better rate that is offered by RFQ. The way this works is there's some off-chain private system where market makers can provide binding quotes for a trade, for this trade, for instance. And maybe they don't know which direction it goes, or maybe they don't even know how big it is. It depends on the system. And then it's binding for a certain amount. Now, because of the finality, because of the block time of, say, Ethereum, where most of the big volume trading happens, are those quotes valid, I think, with Cow for 20 seconds, 23 seconds, like a bit less than 2 Ethereum blocks. And so that means, as this guy is making this quote, will they not only need to accommodate for a 12-second delay that you would have in an AMM, or sorry, in any traditional system, but they actually need to accommodate for the fact that the market may move into either of the directions over 23 seconds, let's say. So it's even worse. Like, the longer you have in order to like look at the real world, like look at what the price discovery is at the real value, the bigger there's an arbitrage potential. So this is baked in. Like, this has to be baked in the quote. So it does make things better, but it's still not a sex-like experience, if I may say so.
two details you're missing here. If you have to accommodate for market moving either this way or the other way, then on average it's going to even out.
No, well, yes, but you as a quota, you want to give a quote that's going to be attractive to you if a sophisticated actor, and there's going to be bots, right? consistently waits out 99% of the duration and then looks, hey, do I want to accept this or do I want to let it elapse? So it's consistently gonna be abused. Like it's gonna be a consistent effect.
So I think there's, if you go to the slide about front running and back running, I think that works a little bit differently than what you're describing.
Which slide?
You have that.
Just the.
For example, sandwiching.
Yeah.
I think sandwiching doesn't really, at least this is what I understood from your presentation. Sandwiching doesn't leverage the information of the move of the price on the market.
It does not, exactly. That's a separate problem to fix. So by sandwiching, I mean you want to sell 1 million ETH, and I see this on units of V2.
You move the price a little bit.
So I know the price will move, so I just send a transaction to like in the other direction right before this transaction, and buy a lot of ETH for the million. This transaction goes through, and then I send a transaction right after to sell my ETH again, now that the price has improved.
I think map is a better description of front and back running. Because front running usually means front running in the mempool, and back running used to describe a very specific technique that was possible on GAF back in the days, that you could wisely prepare a transaction to fit right after another transaction, which they fixed.
Oh, okay. I didn't know this was.
Running could be also on the market, just
Yeah.
on any
Yeah, I'm just saying map
Yeah.
is more precise what to describe it, because front running usually, at least in my mind, refers to front running in the mempool. Map specifically allows you to do dry runs and many other things that general front running doesn't allow you to do. Like for example, dark forest kind of, again in my mind, specifically refers to observing the mempool and doing things based on that. Then when sandwiching in my mind works in a way when you connect directly to the API of the miner, and you can sandwich, like take a transaction from the mempool, sandwich in 2 different transactions, and it's going to be dry run by the miner, and it's only going to be included in the lock if the miner benefits from the free transactions. Right?
But I think we talk one topic in 2 contexts. Here is your one context,
Sandwiching.
but when I want to buy something on the market, I could be also front running.
Yeah.
So front running, I think, could be also considered as an umbrella term for math, mempool front running, and a bunch of other front running.
So I think generally, front running would happen on a SEX as well if the user intention to trade were public. So I think I'm told in traditional finance world, it'd be a very big thing, a highly badly penalized offense to use insider knowledge of a SEX, of an exchange, let's say forex exchange, about user intents, because the exchange obviously has them, and the sysadmin having access to the MySQL could look at it, and that gives you a huge benefit that you could use, and so there's all of the laws and regulations against it. Now we could prevent sandwiching by having an encrypted mempool. I think that's basically the simple way of thinking it. If we can somehow hide the transaction that is about to be executed before it's executed. So there is obviously L2s and zk rollups specifically doing that. I think there's a DEX on ALF0 that tries to achieve that as well. Any more questions? Or maybe now, so that's basically what I wanted to share with you, and now have some space for discussion. And I'd be curious to discuss the security assumptions and how you feel about the SGX.fail risks in a system in a situation like this. I think we can go back to that if that's still of interest. I think Leon, you've had something, or did
No, it's just that when talking about RFQ, you told that you can cancel 99.9% of orders, but I think that's the promise of RFQ, that because it's tied to the address, and it's hard to generate multiple addresses with tokens and allowances, you can just ban out the users for RFQ who cancel 99.9% of the quote, and then you have the guarantee that that's coming is the retail only order flow with, I don't know, 5% of mixing from professionals, which don't ruin it, and then you know that it will eventually cancel out statistically, so you can be more aggressive with your market making, which is not possible.
I don't think that's true. So I think this is true for the market maker side. So if someone is a big guy with a lot of capital willing to make money of fees, you actually need, like the way cow works nowadays is apparently there's like a 1 million stake that you need to give to cow before you are allowed to participate in this permissioned whitelisted RFQ system in order to prevent people from yanking the funds. But on the user side, I don't think you can do that because it's a perfectly valid assumption to make that the user sends the transaction and then waits for it to like reach the system and then receive a response, and it's perfectly valid to assume they will be taking 5 seconds or 10 seconds to like even get it and look at it and like make up their mind if they want to actually do it, or maybe like there's going to be delays, right? So I don't think you can distinguish systematically a bad actor acting in bad faith. Like you could do maybe machine learning or something and just penalize people who are making profits. I'm not sure that's good enough, right?
Sounds like a revolution. So
Because it's hard to differentiate.
To run DEX is basically to run DEX in T, and but also validate it later with traditional zkWarsaw.
Exactly. Or with
settle T quite often, like at
yeah.
or whatever.
Yeah.
But settle zk every few minutes or so.
zk, actually, what we are thinking, what we are deeming as our current favorite is actually a sidechain with a validator set, whose only duty is to verify user intent signatures, and to have this to have this situation where if the T is completely compromised, will the T be able to rearrange the orders arbitrarily and execute suboptimally, like basically sandwich attack the user, LVR with the user and so on, but they will not be able to move funds on the L1 against the user intents. So if I sign an intent where I want to swap 1 Bitcoin for USDC within some range, it will either go through or it will fail, but it will not be possible for a T to steal those funds. So that would be the role of a sidechain with validators who check signatures and then create a validator set signature that is sent to the L1 alongside the T execution signature. Then in order to steal funds, would you need to compromise the T and have a 3+1 majority, depending on the consensus algorithm, in validator chain. And those stakes could be variable, I guess.
You could have most of those benefits that you described without trying your own chain. You could implement a solver beside TE today.
Yeah.
Protect the privacy of the orders of the
Yeah.
users and do the coincident of wants part
Yeah.
in this TE and settle it however the solver usually settles it.
Yeah.
Without running your own chain.
So you would put the solver in a TE, and how would they solve?
The guy who solves the events. Yeah, but because what are the benefits? So let's just unpack it, right?
Yeah.
And let's imagine we have those two different designs. So
Yeah.
what are the benefits of having your own, Validium layer 1 that's
Yeah.
it's not having it.
Yeah.
Right? In terms of this privacy discussion, it doesn't add anything.
Yeah.
Right?
Yeah, so I think this, you don't need to think about the DEX like that in terms of an L2. I think it technically would be, but it's something kind of different in terms of...
But wait, if you
So I think putting a solver in a T is a pretty neat way of saying this. Yeah.
But wait, if you put it in this request model, then
Yeah.
the secrecy of is leaking through the solvers.
You can put all of those solvers into a TE. You can set a prerequisite where if you want to be a market maker in this system, you put your proprietary algorithm into the TE, you attest to us so that we know you're serious about market making, and then we send you quotes and you commit to them. You sign the message or whatever. Right?
Yeah,
you
but
do
those DEs might require external markets to make estimation.
And that's possible. That's the beauty of
You
TEs.
can also force them to use a single source of truth so that they can only market make on their inventory without
Yeah.
using external information. So that would, for example,
But I don't think that's how that works in practice. I think in the practice they have to touch existing liquidity on chain.
but they know what their liquidity is block by block.
So then you put like a Ethereum node or Optimism node inside TE as well.
You just need a header.
Well, you need header and all the data. All the
But
liquidity.
you can keep it. Like you don't really need to know what is the status of your inventory as a market.
So you need to keep the status of all the inventory in TE.
You only need to
And header for validation in the sense, I understand. So in that sense you don't need to change the whole Ethereum.
yeah, you don't need to store the whole information about the whole chain in the TE.
But then you need to audit every single solver before accepting it on the network.
Not really.
Hmm?
Not really. You can you know, create an open source audit of some market making algorithm, right? And then you can have people side load their algorithms at runtime because you don't care about algorithms. Right? You just care about the framework. So you know.
I think, I might get wrong, but algorithm is secondary to liquidity. Like you can do cheaply because you have access to liquidity, right?
Okay, but you are not leaking the algorithm. I'm not saying this is a
No, I mean
design
the
algorithm.
storing, it's not the I mean both algorithm and the storage of liquidity are custom probably. Like some solvers gonna use existing liquidity on chain, some solvers gonna have its own liquidity and so on, right?
Yeah, but I don't see any problem with that necessarily. Like you can again you can take a header from the current Ethereum block. You can maintain your own database of an inventory of chain in your DE, right? So you
Yeah.
know what is the status of your inventory, and you don't have to attest that as a part of DE.
That part I don't understand. Why don't you need to access?
Okay, so
Because
You don't
otherwise
have-
maybe I'm just
sure.
calling, doing some TCP connections and doing stuff, right?
But you don't need to do a TCP connection from the enclave side. You don't need to
And also you could decide to allow that,
Yeah,
which I think is pretty interesting.
I don't agree with that.
No, what I'm saying in general, it's hard to accept something that you didn't audit because there might be very different strategies and
Sure.
when it comes to both algorithms and using external information, right?
No, well,
So
there's
in
going to
general,
be-
every single solver would need to be audited, right? Maybe we would end up with 5 or 7 different type of solvers and maybe some of them would have some small exchangeable part that you can exchange without doing audit, but in general, I imagine every solver might have very different custom strategy and very custom source of data.
Sure. I think we are disagreeing a bit on where is the exact what is the trusted computing base that we audit. Right? So if I'm running this solver network, what is exactly that you need to be convinced of that you are doing as a market maker?
Yeah.
And I think like the size of the trusted compute base, does it encompass the solver's algorithm or how they query the data? Right? I just think
But
it's
how
the
they fetch the data.
yeah.
And the algorithm, I assume you can, in TE, you can forbid it from querying querying memory outside TE or doing TCP connections or
Like
any I/O basically.
yeah, so like the details are sketchy, on how this is supposed to work, right? Because we could disagree on But I think, you know, in principle, we agree that you can protect the privacy of the solving algorithm here, right?
Do you guys follow?
We could like.
I'm not
put
fully
out
convinced you would be able to do, let's say, generalize. I think you would still need to audit. Maybe. Okay. Well. Okay. So there are two possibilities. You either need to audit every solver, or maybe you can do some general solver and have a module.
So why not allow
Which
external?
I'm not convinced yet, but willing to believe that there might be a way.
Okay, so just a quick picture. You know how WASM works?
Yep.
Okay, so you can run a WASM virtual machine in an enclave. Yeah, okay, so there's this extension of WASM called WASIX or whatever, and it allows you to plug a file system with networking capacities into WASM virtual machine, which is usually not there. It's just like a simple, you know, stack machine. It doesn't have what do you call it? External effects or whatever.
Yeah, side effects.
Side effects.
No I/O.
Yeah. So imagine that you're building this enclave for solvers, right? And you audit it, and there's this VM executor.
That doesn't have I/O side effects.
Sure. So you don't have to worry about that.
Yes.
Right? So you are those solvers and you tell them you can do what you want within this virtual machine. You can plug your algorithm there. I'm not going to be able to see it. At the same time, you can explain to everyone that this system checks out because it's audited, and the WASM execution environment is also audited as well. Right? And then you can, if you want, you can control the access to networking on essentially per enclave basis by testing that an enclave has enabled WASIX policy with whatever file system permission. Right? So you can granularly make that possible for solvers if you want. So the design space
But it
is
still doesn't solve the input. Like there needs to have some kind of input they work on. Right? So I follow you there. There is algorithm you can run in theory in isolation, but where do they get data from? And how we know they don't?
But why do we? I'm just asking, right? Why do we care where do they get the data from?
So in theory, you could only read data but not be able to write data. Is that what you say?
No, I'm just asking, you know, as a solver, right? Or let's just say, as a designer of this solver network, why is this a problem for me from a design perspective that solvers will be able to access some data? I don't know what kind of data, right? I'm just saying.
Well, I need to do in a way that they don't leak the data or effects of internal computation.
Okay, so.
Just maybe pure engineering / architecture problem. Security.
Okay. So we are suspecting that by allowing, for example, file system access for networking access (I/O), they will be able to leak some information.
Exactly.
Okay.
So we need to pull data somehow. How do we do that? If we custom algorithm, then we maybe need to kind of audit the algorithm.
Sure. I'm like fairly confident that you can have like a similar granularity of, you know, permissions to file system or networking in LSGS. So you can, you know, control that on the level of, you know, the WAS virtual machine, but you can also say that, you know, this enclave is has this specific interface that you use to put data into it, and that's it. You can only like read, you know, memory from this variable.
Yeah, but then the memory has some information, right? You would need to talk enclave to enclave directly.
True. This is how people usually do this. People start and terminate TLS.
Deliver proof of concept.
In that particular solution that I would work.
I think the
It's already been done. There's this company called Fortran Sys1, but the other one was from Red Hat, and they actually actually build this mesh network of like WASM executors in JS. It's actual software.
Using?
And it's the code of
Did
the
you say secret network? Like
no, it's secret network is puzzle.
I think an alternative would be to, for instance, have a specific endpoint that an SGX is allowed to query. For instance, the Binance price feeds. And we say, okay, we add yet an additional assumption to our trust list, trust assumptions list. Binance can steal funds or influence prices, right? And then the enclave can ask this specific endpoint to fetch pricing data.
So for example, there is this exchange. They happen to have a few percent of all swaps on Ethereum, and they do it with a remarkably low amount of liquidity. I believe they have $4 million liquidity total on the exchange. So that's funny. And the way they do that is they don't. They have interface. I don't think anybody uses them. I think the traffic is made by solvers. So they access their own, just making very efficient use of their own liquidity. So in other words, they need the data from chain. Right?
Yeah.
The question is, how do you deliver the data? You have this on-chain smart contract. How you deliver the data into the security?
Oh, securely is a
No,
problem.
with security assumptions you mentioned, right?
Well, you could increase those as well, right? And you could say, hey, we allow fetches from RPCs. Like these 3 RPC providers need to agree, then we deem it true. And then you have like all of one instant any RPC queries that are somewhat trustworthy. If you use this for like a temporary period only, I think this is a plausible use.
Need to still.
And of course, you do SSL checks, right?
Check the private keys.
Oh yeah, of course. But that's, I think that's pretty straightforward.
Why not to use just sexes instead of allowing to get price feeds from sexes and whitelisting them?
As a
Why
term,
just not use sexes?
as an interim thing, because well, not really, because this is an interim step. Like this is as long as a big portion of price discovery is happening on Binance that you care about that. Like the more people use DEXs, the less will you be faced with this. And this is just a simplified example. I think what you would do as a market maker in the real world is you would be interested in several data sources, like Twitter and the weather and whatnot, I don't know, and aggregate all of that. And I imagine there being a space, a niche for a marketplace for these that could then be decentralized, and it could be put on some, I don't know, like high frequency AVS or something as Oracle input with some consensus and some guarantees. And then you look at them, and so you lower and lower and lower, like reduce the trust assumptions as you go. I think that would be the way.
An interesting consideration would be how do you tap into existing liquidity?
Well, you need
But
to
that makes it
talk to
more-
aggregators and have them include you. You need to talk to market makers, have them go to you.
How it differs from like GM networks that you send the intent that you want to make a transaction for some amount or some perf, and then this transaction is executed with the price from Oracle, which is like from the moment when you post the intent. So it can be front on the left because the price is old, like from the moment that you post it. The only
So this is for market orders, yeah?
yes. The only assumption is that you trust the Oracle, which
Yeah.
put the price. So it's
Who's the LP? And what's the, because the LP might have a lot of loss this way, right? This way the LP takes all the loss.
users.
Yeah, but so it's I need to opt in. It's like is it like Uniswap? Like I put my liquidity there and get fees, right? Well, so then I guess
But people are putting their money because
I know, yeah. Well, I guess it's early, and people don't understand impermanent loss, and they put money on V2LP as well. But I think this is a sign of an early stage. So I think I didn't look at this at depth, but the way I would explain it in my head is, well, yeah, sure, like it's great for the user, but the LP will be taking all the loss from the LVR.
And she makes you deposit into a basket of assets.
Uh-huh.
So the impermanent loss is reduced across them.
Okay, sure, but they are probably correlated like by 0.9, right?
Like
Like all stables are correlated and everything else is correlated, I would say. So,
there's no free lunch.
yeah. So I would assume this is taken by the LP, and so probably the fees are high, and so probably the execution is worse for the user.
Decide to withdraw a single asset, is paying
Yeah.
dynamic fee.
Yeah.
It's
Oh,
still-
it's dynamic.
Yeah, it's still less than the impermanent loss, they would agree.
Yeah.
But someone has to pay up.
Yeah, exactly. Yeah. So I guess the solution to this is have freaking shorter block times. All right, I think it's time for drinks. Thank you so much, guys, and see you next time. Where are